So in this lecture, we'll discuss about active loads, swing limits, and some problems. So if we consider the common source amplifier, what is the small signal gain? It is minus GM or D. Now, if I want to increase the gain, what can I do? How can I increase my gain of my amplifier? What are the possibilities?
We can increase GM or RT.
Okay, one option is to increase GM, and the second one is to increase RD. In this case, what happens if I increase GM?
It is
ID
dependent
increase,
on ID.
depend on ID.
Okay, it is dependent on ID. So what
Variable,
happens?
variable,
Temperature dependent.
jump.
Okay, we are not worrying about temperature dependency. I'm worried about something else. What happens if ID increases?
Something gate voltage decreases. Gate voltage decrease అవుతుంది.
What happens if ID increases? What is the DC output voltage?
VDD minus ID.
So if ID increases, what happens?
ID increases.
VD becomes
VD.
low.
Hmm.
If this goes up, this
This
comes
goes slow
down.
down.
So does VD has a limitation on it going below? If so, what is the limit?
One VD can go one over the on VT only.
Edge of saturation.
Edge of
What
saturation.
is that condition? What is that
VD is
condition?
equals to VG minus VT.
VG minus VT. It can be below 1 VT.
As you increase ID, if you increase ID, your GM goes up. Because of that, your gain goes up. Because of gain going up, this output voltage will come down. That I will write.
Hmm.
Instantaneous voltage V naught, sorry, V naught is equals to V naught DC plus V naught
V not
AC.
AC.
Okay, what is V naught DC? V naught AC is GM RD times of VA. Okay, You are giving input Vn, so the output becomes as minus GMRD times Vn. So if I increase ID, V0 decreases.
Decreases.
So we can't achieve
Achieve.
significant gain by increasing
Increase GM.
VM because of
Because of output is
because
increasing.
of swing limits.
Swing limits. Oh, oh.
What can I do to improve the swing limits? What can I do?
I don't know.
Can I increase VDD? What happens if I increase VDD?
VD increase.
reading,
VD increase.
If I increase VDD, I can have a much more drop across RD. Is it? If I increase VDD, I can accommodate more drop here. I mean, the drop can be more here in this case. Even then, it will be in saturation only. See, if my VDD is 2 volts, let us say the saturation condition is zero point 0.5 volts. The difference here is 1.5 volts. In the other case, if I increase VDD to 4 volts, still this condition for saturation will be zero point 0.5 only. But the range I have here is
3.5.
3.5 volts. So if you increase VDD, you can get more swing limit
Limits.
and gain. Okay, by simply increasing ID, I will get gain. I will get the required gain, but my amplifier will not be in saturation region. MOSFET will not be in saturation region. To do that, I have to increase my VDD. Okay, so we can't go increasing VDD how much ever we want. It will have a limitation according to the technology. So for current technologies, VDD is 3v3, 1.8, 0.8 volts. So we can't go increasing VDD. So we need some solution for this. What is the solution? I hope you guys are getting it. If not, you can ask at any point. Is it clear? Same thing in the second case also. If you increase RD, what happens? This drop will increase. So VD comes down. You will have the same swing limits problem. In both cases, if GM increases or RD increases, the drop across RD increases.
So this V naught comes down. Because of this, you will have the change of region issue. Okay, is it okay?
Okay.
Others,
Okay.
Harshit, yes.
uh,
Yes. So you're telling that if GM and RD both are increased, the V naught will decrease. But if we increase VDD, the MOSFET will be in saturation region. But there are
yes.
some limits. You're asking what are the limits like if we increase
See,
VDD.
you told correctly. If you increase both GM and RD, this drop across RD increases, and as the drop increases, this voltage goes down, and it can go 1 VT below VG. So it has a
AC.
limitation at the output voltage. Okay.
Okay. Okay.
If I increase this VDD,
Okay.
I have much more swing here, right? The drop can be more right now.
Yes.
If the drop can be more, the current can be more, or the GM can be more, or RD can be more.
Hmm.
In those three cases, my gain can be more.
Okay.
Okay,
Okay.
that's what I'm trying to tell. But we can't go increase VDD how much ever we want. VDD has a limitation on it. So we need an alternative solution to this. So
Okay.
other solution for this is active loads. See,
Okay.
for higher gain, the resistance looking from this point up is R up should be high, and the drop across it should be low. Okay,
Okay.
so what I should do? I
Hmm.
should connect some block box here.
Impedance.
VDD.
VDD. Ground. V in. Easy plus V. V.
So the resistance looking up should be high, and the drop across it should be low. What can this element be? Which element can we use?
Current source.
Current source.
Current source. So we can use current source.
Not really.
What is the resistance looking up?
Infinity.
Might one.
Looking down?
1 by GM.
Infinity.
1.
Infinity. If lambda is equal to 0,
Infinity. R down is equals to.
R
Lambda
down
is
is
equals to not
infinity,
equal to 0. R naught.
lambda not equals 0, R down is RDS. So here in this case, you can have a 0 volts drop also with ideal current source. With ideal current source, 0 volts drop is also possible. But in practical, ideal sources won't exist. Correct.
Okay.
So we have to implement a current source, if not ideal current source, it should be towards the current source, more like a current source. The output resistance should be very high, and the voltage drop across it should be very low. So what I will do, I will replace the current source with the MOSFET.
Cascading ಅದೇ.
Consider lambda. What is the output resistance here?
R not 1 అదే RDSP
This is or not?
RDSP
Yeah, RDS or not. This is also RDS. So what is the gain? Gain is
M1 అది RDS ఉంది కదా
anyone.
RDS parallel RDS minus GM RDSN parallel RDSP
Anyone.
ఇది గ్రౌండ్
Gain please.
GM RDS.
How can it be GMRDS?
minus GM RDS
GMRDS
parallel
by 2.
RDS parallel
Yeah, it is minus GM1 RDS
RDS
by
RDS
2. Okay,
RDS better
so here you got good gain. I mean, RDS will be in the order of kilo ohms
okay
or some
okay
tens of kilo ohms.
mm.
Okay, but the voltage drop here, DC, what is the minimum DC required here from this point to this point?
zeros 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 simple I think zero
See, I will tell you. At the edge of saturation, what is VDS?
VDS is equals to VGS minus VT
VDS is,
VGS minus VT
so I will call this as VD sat for PMOS. It is
VG
VSG
why you going to VHV again
minus VT. This is the minimum voltage required for the PMOS to be in saturation.
hmm.
Okay, so this is VD sat P. So what is DC voltage V naught? V naught DC is
Hmm?
VDD minus
minus VDS
VD sat P. So this VD sat P will be in the order of some zero point 0.2 volts, 0.25 volts like that. Whereas when you have RDS, it will be around 1 volt, zero point 0.8, 0.9 volts, depending upon your current value. So here, as we required, you need lower drop across the element, which is the load, and the output resistance should be infinity. So we are near to that. So the drop across this MOSFET is very less, which is VD SAT P, which will be in the order of zero point 0.1, 0.2, 0.25 volts roughly. And the output resistance looking up here is RDS, which will be in the order of hundreds of kilo ohms based upon your current. Anyhow, RDS also depends upon the current. RDS is 1 by lambda ID. So RDS will be tens of or hundreds of kilo ohms depends upon your current. So the solution for the
ऐसा करते हैं
problem
अच्छा
which we have faced,
दीवार पर
that is swing limits, is to have a active load, which is a
आप
MOSFET.
ऑफिस में गए थे पूछना
So what you have to take care here is you
मैंने
have to
देखा
set your bias currents properly. This bias currents properly. Then you can
हम
achieve.
रिपीट इट अगेन रिपीट इट मैं మీ వాయిస్ కట్ అయింది
Which one?
ఇక్కడ హాఫ్ నుంచి కట్ అయింది కరెక్ట్‌గా
Is it the same
చెప్పలేదు.
with the others or only Sadik? Hello, or
Only with
others?
Sadik Anna.
Then I am not repeating. Okay, what I am telling is earlier, earlier, see, I will just repeat briefly in 1 or 2 minutes. What we are looking here is we want to increase the gain. Okay, gain depends upon GM RD. If you increase both GM and RD, the voltage drop across RD increases. So you are going towards saturation region. Sorry, you are going towards triode region
ట్రయోడ్
if you
రీజియన్
increase the gain. So yeah, you have a limitation upon the gain to be in saturation. For that, what we have done is we thought of using current source. Current source has a 0 volts drop, can have a 0 volts drop across it, and a output resistance of infinity. In practical, we will not have ideal sources, so we have to go towards the ideal sources, which is to have as much as low voltage
నియర్
drop
బై
and as much as
హై
high resistance
హై
as
రే
possible. So here we have achieved it with the MOSFET, which has a very low voltage drop of VDSAT P, which is around some 0.2, zero point 0.3 volts, and a very high output resistance of RDS, which will be in tens of kilo ohms. So with active load, we can get good swing limits and a reasonable gain. Is it okay now?
ఓకే యాక్టివ్ లోడ్ కరెంట్ సోర్స్ హై
Because of high output resistance. This is because of low voltage drop.
No voltage drop.
Okay.
Hmm.
See, from the starting of the lecture, I am saying that swing limits, swing limits. What are the swing limits? What is happening exactly in the common source amplifier?
Counter champion gain increase the కాబట్టి counter champion అంటారు అంతే కదా.
So you have your gate potential here. Let us say drain potential is here, which is at VDD minus IDRT.
ID RD
Okay, and this gate potential is at some VG.
VG VG అంతే.
Okay, so essentially, while we are applying a small signal voltage, what is happening is you are applying a sinusoidal here.
Hmm.
Let us say we are applying a sinusoidal input voltage. So as the input voltage increases, what happens to the current? ID?
Current is zero.
ID is given as
GM VGS no.
Gm times VGS.
VG.
As VGS increases,
ID increases.
ID increases. So this small signal voltage V0 is minus Gm VGS RD or minus ID RD. As ID increases, what happens to V0?
V0 V0 should be
Decreases.
decreases.
So V0 decreases. So as VGS increases, this V0 will decrease. So V0 will decrease by amount of gain.
V hmm. Hmm.
What happens when VG decreases?
V0 increases.
If this goes down, ID goes down. If ID goes down, V0 goes
Up.
Increases.
V0 goes up. So V0 increases.
It's inverter. Simple. Just invert the signal with the peak of height.
What is this voltage? Instantaneous voltage at this point is VDD
Minus
minus IDRT
RT
minus
GM VGS
GMRT
at
times of
VG
Vn.
in
Can it go till zero? Can the drain voltage go to zero? Anyone?
అసలు డ్రైన్ వోల్టేజ్ కప్పి జీరో పోదు. యాక్చువల్గా డ్రైన్ వోల్టేజ్ జీరో పోదు కదా.
Can the drain voltage go to 0? Come on.
డ్రైన్ నుండి జీరోకి వెళ్తే ఐడియా వర్క్ అవుతుంది కదన్నా. No,
MOSFET turn off, sir.
MOSFET?
టర్న్ ఆఫ్, కరెంటే ఫ్లో అవ్వదు కదన్నా.
Turns
See, the
on.
question is, can it go to 0? What happens if it goes to 0?
ఓ,
What is the transition point?
అంత తెలియదయ్యా.
VDS should be greater than 0.
జీరో.
Yeah. At any point, VD should be greater than or equals to VG minus VT.
VG మైనస్ VT.
As we discussed earlier, VD can go 1 VT below VG.
VG.
Okay, this difference this difference can be 1 VT. What happens if it goes below 1 VT?
MOSFET will turn off.
MOSFET will enter.
In
Triode
intraid
region.
region or triode
In that
region.
case, what happens? You will not the required gain. You will not get the required gain. Okay, the gain is not same for both saturation and triode regions. ID is half K
VGS minus VT whole
VGS
square.
minus VT whole square. This for saturation. We have our GM equations.
2ID by
2ID by VOV
uh,
half
half mu n, root 2
mu n
mu n
Cx
squares
W by
omega
L
by L
into
VGS minus VT.
VGS minus
VGS minus
VTH.
VT.
In triode region, what is the current equation?
Mu n COX VGS minus VT
Of
into
K VGS
VGS
minus
minus VT
VTH into
VDD
VDS
square
minus
VDS minus 1 by
of VDS
whole
square.
square. That's
What is GM here?
root over 2 idea.
GM is
తెలియదు.
Neon Cx W by L into VDS.
yeah.
Yeah?
Sorry, this half will not be there, right?
Yes.
K times VDS. Muon Cx W by L into VDS. This is GM
ఎందుకురా?
saturation is GM triode. What
Okay.
is the relation between these two? Which one is higher, which one is lower? If so, why?
యాక్చువల్లీ వీడియస్సే ఎక్కువ ఉంటుంది. సింపుల్ మీన్స్ ఒమేగా బై రెండు ఒకటే తీసేస్తే
What is the
వీడియస్
relation?
ఎక్కువ ఉంటుంది.
Come on.
GM saturation should be greater than GM triode.
Why?
For
It
triode
is,
region, VDS should be less than VGS minus VTH.
yeah, here this VDS is less than this value, VGS minus VT. Okay. So when this when the drain voltage of the common source amplifier comes 1 VG below 1 VT below VG, what happens? It enters the triode region. So there you will not have the enough gain. So it will not follow this curve. It will not follow this curve here. So it clips off because of the lower gain. Here it cuts down something like this. And then follows the curve, this curve. Okay. Do we have any limitation on the upper side here? Do we have any limitation here?
No, no, it cannot go వన్ అబౌవ్ వీటీ అలా ఏం లేవు కాబట్టి no. ఏం లేదు నాన్న అక్కడ
What is happening in this case? VG is decreasing, so ID is decreasing. So the instantaneous ID is
ఐఏసి ఐఏసి ఐడిసి ఈజ్ ఈక్వల్స్ టు జిఎంపిఐ
what happens if VN goes down? See, you
ఐడి
have certain why ID will increase. You have certain DC current, let us say some 2 milli. It is decreasing as you decrease the VGS. At some point, it should cross zero, right?
యా
Hello.
ఓకే ఓకే
If ID becomes zero, what is it called?
అరే ఐడియా బికమ్ జీరో అయిపోతే
Cut off.
ఇట్ ఈజ్ ఇన్ కట్ ఆఫ్
This becomes zero. Let us call this as V in max. V in max 1.
నాకు గుర్తొచ్చింది ఇదిరా మనం చేసేది అక్కడ
So we have other condition which is VDD
మైనస్
minus
ఐడిఆర్
IDRT minus
మైనస్
GMRT times
విఎంఆర్డి
VN
విఎన్ ఈజ్
equals
ఈక్వల్స్ టు
to
జీరో యాక్చువల్లీ విడి
VG plus VI minus VT. 1 minute, I will explain these things. See what I have written here is the same condition, this condition. So on the left hand side, I have written the instantaneous VDS voltage, which is nothing but your
PD plus
DC value
PD plus
plus the AC value. I
AC
have
value.
written this on the left side. On the right
Uh,
side, I have written DC VG plus here we are applying some small signal voltage VI, that I have written minus VT.
uh, uh,
Is it okay?
okay.
Okay.
So if you simplify this,
Which is maximum is
this is
other
the
side.
V in max you will get on the other side. Okay.
Hmm. థియరిటికల్గా ఇవాళ తెలిసింది ఇది ఎలా వెళ్తుంది అనే దాన్ని బట్టి కట్ ఆఫ్కి వెళ్తుంది కట్ ఆఫ్కి
So
వెళ్తే ఏమవుతుంది.
essentially, what is happening here is when your input voltage is going up, when your input voltage is going up, is output voltage is coming down. When the
డౌన్
voltage goes down, it enters into triode region. So and when the input voltage is going down, this output voltage is going up. When the output voltage is going up, your current is becoming zero at some point,
జీరో.
which is nothing but cutoff region. Here also at the output you will have some limitation due to ID, which will cut your output voltage because of the gain. And in cutoff also you will not have any gain. Okay. So these are the swing limits. Ultimately, the max
This one
input
is what we
voltage V in max is
is
minimum
minimum.
of these two voltages. V in max 1, comma V in max 2. Is it fine?
Fine. It's okay. Done. ఇది చూస్తాను ఒకసారి చూడాలి చూడాలి.
So I have discussed active load swing limits. So we'll quickly solve one problem and say
గుడ్ బాయ్.
goodbye.
ఒక ప్రాబ్లం కరెక్ట్ చేద్దాం. నాకు అర్థమైతే చేద్దాం. చేసాం ఆల్రెడీ గుర్తురావట్లేదు. తెచ్చిపెట్టాడ్రా.
Is it clearly visible or not? Can you read this?
యా.
How to find V1?
Hmm?
We should find I1.
I1.
We should find this value I1, V1. Can anyone help me? How to find I1 and V1? What is the current flowing in M2?
1 million. Million.
1 milli.
Hmm. Yes.
2 million.
Sorry. 2 milli. Omega L is. W by L is
So
20.
what is the voltage here? Voltage across
4 volts.
4
4
volts.
volts. So what is the relation
Hello.
between VGS and
2 milli వస్తుంటే voltage is equal to
ID?
IR
VGS is
into 4 volts.
VT square root of
Root over 2
2ID by mu
VGS,
amp.
VN by
Millions.
root over
Yeah.
W by L.
Can anyone solve for VGS? It is nothing but 2 volts. So VGS is 2 volts. This node potential is 4 volts. What is this node potential? Hello.
6 volts.
6.
So what is this potential?
VGS is 2 volts, 4, 6 volts. Correct. VGS is equal to VG minus VS raw. VG is equals to 2 plus 4, 6 volts. సేమ్ VGS ఉంటాయి, సేమ్ కరెంట్ ఉంటుంది.
So
సేమ్ VGS కాబట్టి
the
4 volts.
quiescent current across flowing through V1 is 0. When it will be possible? It is possible when V1 is 4 volts.
4 volts. Then it
If
is
you
open.
remember the previous class, I have told this. Okay, go check the PDF. So V1 is 4 volts. What is I1 if no current is flowing here?
1 milli.
I1 is
1
1 million.
1 milli.
1 milliamp. So next what they have asked is determine the small signal gain of the amplifier from V into V naught. Now how to solve this?
This is 1 by GM ra. This is 1 by GM. It is open circuit. The open circuit with 1 by GM. 2 kilo ohms. ఇచ్చేసాం మనం.
Yeah. In small signal analysis, what happens to this circuit? This voltage source goes off, current source
Current
is
goes
open,
up.
this current source is open,
FCM short. ఆర్నట్లే తీసేయడమే ఇంకా.
this is shorted, short circuit,
It's
here it is
working as
open
a
circuit,
1 by GM.
here also it is open circuit, it is
The
connected to
ground
ground. This will be
uh,
Short
shorted.
shorted
circuit.
to ground. So here if the voltage is Vi, what is the voltage here?
Same, working as a 1 by GM, right? Then VG is equals to
If you draw a small signal circuit,
hmm, source.
what is GMVS here?
Same 1 volt ఉంటుంది.
How much is the GMVGS? Is there any way to flow for the current? Where will this current flow?
No, no, no.
Let
Still
us say
current
this
is
current
zero.
is coming from this path, flowing the way. Where will this go?
No, I think so. don't have current source, I think so there.
Shall I stop the class like yesterday, or you people are going to respond? Hello.
Didn't get అర్థం కావట్లే నాకు. Current 1 floor to ground.
So if the current is zero, GM VGS is zero. VGS is zero.
Then it's
Thus
equals
VG is equals to VS. So this node potential becomes VI.
VA.
So what is the gain?
Get GM RD ra. Minus GM RD.
Minus GM RD.
GM RD.
You find these numbers and solve. In the D part, what they have told is, it turns out that the amplifier just clips at both extremes simultaneously for an input sinusoid with amplitude A. Determine A and VDD. So you are going to solve this part D while coming to uh, tomorrow's class. And also part F. Okay, we'll just briefly discuss E and finish this lecture. In E, what are they asking is, a student forgot to solder C1, determine the incremental gain. What happens if C1 is present?
Current splits.
Gain
Current
decreases.
split అవుతుంది. Gain decreases
Gain decreases by
by 1 by SC.
gain decreases by how much?
1 plus GM.
1 by
So the gain becomes
GM RD by 1 plus
Minus
GM
GM RD by 1 plus GM.
uh, R plus RD RS parallel 1 by SC.
okay.
Hmm.
So while coming to tomorrow's class, you should solve these two problems, these two parts,
అరే మొత్తము
part D and F.